Assalamualaikum dear student. Bismillahirrahmanirrahim. Today we will start our lecture on the topic flame test. What is flame test? Flame test is basically a test used to identify the presence of a relatively small number of metal ions in the compound. Not all metal ions give flame colors. For group 1 compounds, flame tests are usually by far the easiest way of identifying which metal you have got. For other metals, there are usually other easy methods which are more reliable. But the flame test can give a useful hint as to where to look. Carrying out a flame test. Dear student, in this slide you will know how you can carry out a flame test. There are some practical details. First of all, take a platinum or nichrome oil, clean it, and then dip it into a concentrated hydrochloric acid, and then holding it in a hot Bunsen flame. Repeat this until the wire does not produce any color in the flame. When the wire is clean, moisten it again with some of the acid and then dip it into a small amount of the solid you are testing so that some sticks to the wire. Place the wire back in the flame. Again, if the flame color is weak, it is often worthwhile to dip the wire back in the acid again and put it back into the flame as if you were cleaning it. A very short but intense flame of color will obtain by doing that. Different colors shown by different elements are given below. You can here see that lithium will give show flame color red, sodium will show flame color golden yellow, and potassium pink, rubidium red, cesium blue, calcium orange red, strontium red, barium pale green, copper blue green, and lead grayish white. The origin of flame colors. Origin of flame colors mean that how you can get different colors by different metals. We have seen that the outer electrons of atom of alkali metal is loosely held with the nucleus, and hence it can be easily excited to the higher energy level even by a small amount of heat energy. During the excitation process, the electron absorbs some energy, and when this excited electron comes back to its original position, it gives out absorbed energy in the form of light in visible region of the electromagnetic spectrum, and hence the color is imparted by the atoms to the flame. Since the amount of energy absorbed during the excitation process is different in different atoms, different colors are imparted by the atoms to the flame. The properties of alkali metal to give coloration in the Bunsen flame has been used to detect their presence in salts by a test known as flame test. Student, there is a small quiz. After completing your lecture, you should be able to answer these questions which are given here in this slide. Now we will discuss some atomic and physical properties of group 2 elements. In this table, summary of the physical and atomic properties of the elements of group 2 elements are given below, like atomic weight, percent abundance, density, melting point, boiling point, atomic volume, atomic radii, covalent radii, ionic radii, ionization energies, oxidation state, electronegativity, flame coloration, oxidation potential, heat of atomization, heat of hydration, ionic potential, etc. are given. Turns in atomic radius. atomic radius increases as down the group. You can see in this graph that from beryllium to barium, atomic radii are increasing. Here you can see why the atomic radii, atomic volume and ionic radii of the group 2 element increasing down the group. Because of the addition of n extra shell of electron to each element from beryllium to radium, the atomic volume increases. With the increase of atomic volume, the atomic radii also decreases from beryllium to radium. The atomic radii of this element are, however, smaller than those of alkali metals in the same here. This is due to the fact that the alkaline earth metal has higher nuclear charge Y, which tends to draw the orbit electrons toward the nucleus. The smaller value of atomic radii results in that the alkaline earth metals are harder, have higher densities and higher melting point than alkali metals. Trends in first ionization. First ionization energy, you can easily see here in this graph that decreases from up to down, means from beryllium to barium. Why the first ionization energy decreases down the group? Because atomic radii increases from beryllium to barium. That's why first ionization energy decreases down the group. Here's a graph which shows electronegative values falling down the group, means beryllium to barium electronegativity values. Now you will see trend in melting and boiling point. You will see here in this graph that apart from where the smooth trend is broken by magnesium, the melting point falls as you go down the group. While there is no obvious pattern in boiling point, it would be quite wrong to suggest that there is any trend here whatsoever. Trends in reactivity with water. Beryllium, it has no reaction with water or steam even at red heat. Magnesium burns in steam to produce white magnesium oxide and hydrogen gas. Very clean magnesium ribbon has a very slight reaction with cold water. After several minutes, some bubbles of hydrogen form on its surface and the coil of magnesium ribbon usually floats to the surface. However, the reaction soon stops because the magnesium hydroxide formed is almost insoluble in water and forms a barrier on the magnesium, preventing further reaction. You can see here reaction even below. Summary of the trend of the properties down the group. As the metal atom gets bigger, any bonding pair gets further and further away from the metal nucleus and so is less strongly attracted toward it. In other words, as you go down the group, the elements become less electronegative. As you go down the group, the bonds formed between these elements and other things such as chlorine become more and more ionic. The bonding pair is increasingly attracted away from the group 2 elements toward the chlorine. Calcium, strontium and barium. These are react with cold water with increasing vigour to give the metal hydroxide and hydrogen. Strontium and barium has reactivities similar to lithium in group 1 of the periodic table. For example, calcium reacts fairly vigorously with cold water and exothermic reaction, bubbles of hydrogen gas are given off and a white precipitate is formed. Together with an alkaline solution, the equation for the reaction of any of these metals would be given below. The hydroxides are not very soluble, but they get more soluble as you go down the group. The calcium hydroxide formed shows up mainly as white precipitate. You get less precipitate as you go down the group because more of the hydroxide dissolve in the water. Explaining the trend in reactivity. Beryllium hydroxide is not at all basic. In fact, it is amphoteric since it reacts with acid to form salt and with alkalis to give beryllates. Here you can see the chemical reactions both with acid and hydroxide. The hydroxides of other metals are basic in character. Their basic character increases on moving down the group. Thus, magnesium hydroxide is weakly basic while barium hydroxide is the strongest base. The increase in basic character of hydroxide on moving down the group is due to the fact that with the increase in size of metal of cation, both the polarity of magnesium hydroxide bond and the internuclear distance between oxygen of OH- ion and the metal atom increases. As a result of this, there is a great ionization of magnesium hydroxide and hence basic character increases. Due to high polarizing power of small beryllium ion, beryllium hydroxide is covalent while other hydroxides are ions. Beryllium hydroxide and magnesium hydroxide are almost insoluble in water while the hydroxides of other metals are slightly soluble. Their solubility increases on moving down the group as shown by the increasing value of solubility product of these hydroxides. These are all the value of solubility product: beryllium hydroxide, magnesium, calcium hydroxide, strontium hydroxide.